For our last example for graph coloring for 15.5, we're going to take a look at actually coloring a map. So one option is to keep your map. But the problem with trying to color on a map is that we have some really teeny tiny countries in here. For example, there is a little country between Spain and France. We've got countries where it may be a little difficult to see what their borders are. Italy and France, we can see clearly have a border, but it can be a little difficult to see if there is a border between Italy and there's Liechtenstein up in here, right in here, or do Italy and Germany actually touch or not? That can be kind of difficult to see. So what we can do is actually turn our map into a graph. Find the proper coloring for the graph, and we have a coloring for the map. Now remember, since this is coming from a map, we should need at most 4 colors. So let's take a look at our coloring here. I'm going to start the same way I did before. Start by coloring high degree vertices. So Germany, for example, has a pretty high degree. France has a pretty high degree. I think France, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. France has our highest degree in the whole map. So I'm going to start by coloring France, and then anything else that I can color the same as France. So I can color Portugal the same as France. I can color the Vatican the same as France. No. I can color this guy right here in the same color. Let's see. I could color Austria. I can color any of these vertices the same as France and Liechtenstein. So I want to try and make the best choices that I can. If I color Slovenia, I cannot color Croatia or Austria, but I could color Liechtenstein and the Czech Republic. If I color Austria, then I can't color this guy, but I could this one and this one. It seems like my better option is to skip Austria for now and color Slovenia, Liechtenstein, and let's see, I've got Poland or the Czech Republic. We'll do the Czech Republic since its degree is higher. At this point, everything in my graph is connected to a purple vertex, so I need to switch colors. So for my second color, I'm going to do the same thing. Now, my highest degree, my most connected country is Germany. So I'm going to start by coloring Germany and then anything else that I can. No. But I could color this guy, and I could color Italy, and I could color Croatia down here, and then I could color one of these two. So I'm going to choose to color Andorra. And now everything's connected to either a red or a purple vertex. I need to switch colors. Again, I'm going to start with a higher degree vertex if I can. I'm going to color Austria. If I color Austria, I cannot color Switzerland, but I could color Poland. And one of these two, so I'll color Luxembourg. And then Spain I could also color. And now everything that's left is connected to a green vertex. So I'm going to switch colors one more time, switch to blue, and I can color my last 2 countries, Switzerland and Belgium. So our chromatic number here would be 4. As we expected it should be. Now it may be possible to color a map in fewer than 4 colors, but 4 is the most you should ever need. That's our chromatic number for this map. Now there are different ways that we could have colored this. If you pull up the notes on the website, I've colored this a little bit differently. I made some different choices at different places. So for example, I may have chosen to color Austria purple instead of Slovenia. So I would have gotten a little bit different coloring, but your chromatic number should still be 4. If you have to use a 5th color, you've made an error somewhere and you need to go back and look at that. The last thing on your notes is something called the greedy coloring algorithm. I'm going to show you what this is, but this is not what I want you to use. I want you to use the strategy that we talked about in this example and our one in the first video. So the idea behind the greedy coloring algorithm is it gives you a way to color a graph, but not necessarily the graph's chromatic number, and that's what we're after. So the idea behind the greedy coloring algorithm is that you pick any vertex in the graph, disregard which one has the highest degree, and just color the vertex that you pick. And then pick another vertex and color it the same if you can, color it different if you can't. So if I pick this one next, it could be the same, so I color it with that same color. And then I pick another one, and if I can color it the same, great. If not, I switch to another color. So I'd have to switch to another color here. And then I pick another vertex, and I color it the same if I can. If not, I go back to that first color. In this case, we could do that. Otherwise, I would have to move back to a first color. So now if I pick this vertex, it's already connected to both of my original colors. I have to pick a new color for that vertex, and so on and so on. Again, I'm showing you this because it's a way to color a graph, but it's not necessarily going to give you your chromatic number. That's why it's called the greedy coloring algorithm, because if you are truly choosing at random, a lot of times you're going to end up using more colors than you need to. So stick with our strategy of picking those high degree vertices first. Color anything you can that's not connected to those high degree vertices, and then move on to your next color. Your homework is on the next page. You are finding the chromatic number for these first 4 graphs. And then for this last one, you're going to do the same thing we did with that schedule example. You're going to create a schedule. You're going to create a graph. You have, I think you're scheduling a tournament. You have 5 teams. So make a vertex for each of those 5 teams. Every team must play every other team and have 2 off rounds. You're also going to make 2 off round vertices, connect every vertex to every other vertex, and then do your coloring. Create a schedule for your tournament using that graph.